welcome to this week's programming tips. We're going to start with a little bit of debugging, specifically involving programs using sounds. But what we're really going to focus on is code style, because we're nearing the end of the course, and your programs have been getting more complicated, and hopefully after this course you'll continue on this path. So we need to give you some more tools to address some common problems that we see with students' code. So first we're going to look at why can't you play some sounds. So in this program, I run it and it's not playing any sounds. Why not? And furthermore, it doesn't show any error messages. So let's look at the docs real quickly here. Go down to sounds and load a sound. And one thing you'll see here, so there's a note that not all browsers support the same files, so you have to worry about that. But also, no error is erased if the file isn't found or if the format you're trying to use is unsupported. Well, so because there's no error messages, you're a bit on your own. So in this case, I used the wrong file name. I need an extra character there. And so once I fix that, we get some sound. But, I could have been using the wrong format. OGG is supported by Google Chrome that I'm using here. But I could have had a bad file name like I did originally. The network could be down, the file might not even be a sound. And also, going back to the documentation here, sound set volume. Okay, at least by default you can hear it, but maybe you set the volume so low so that you can't actually hear anything. So there's a bunch of reasons that you need to think about and play around with, see what's going on if you can't hear anything. So next we're going to revisit code style. We've been introducing new features such as dictionaries, and we want to see how we can best utilize them. Our examples are going to come from sample solutions to some of your projects and some of the code that we've handed out. But because these examples are coming from sample solutions, we're not going to release the full code. You'll just have to see them on the screen. So here's some code taken from a sample Pong solution, okay, from a few weeks ago. Okay, it's pretty typical. And what we have here, we have a pair of if statements, one to move paddle 1 if it's in range, and one to move paddle 2 if it's in range. Down here we have a pair of draw line where we draw paddle 1 and we draw paddle 2. Each of these pairs is structured identically. Okay, these two if statements, the only difference is which variables are we using, those for paddle 1 or those for paddle 2. Similarly down here, where we're drawing it is almost entirely the same, and how we're drawing it is almost entirely the same. What we would like to do is capture the similarities, get it right once, okay, and reuse whatever function or method we need to actually do the work. Okay, get it right once, and if you mess it up, fix it once. Okay, here we would need to fix it twice if there was a problem. Okay, here's a rewriting in a using functions. We have a paddle move function and a paddle draw function, each of which take which paddle am I supposed to use, okay, and does the appropriate operation on them. Okay, we call the paddle move function and the paddle draw function twice, once for each paddle. Okay, now we've needed to make some other changes, and here we assume that the global variables have been changed. Instead of having a global variable paddle1 underscore POS for the position, for example, we need an array paddle pause, which has paddle pause 0 and paddle pause 1 for the two paddles. And similarly for the velocities, then we introduced also a location array for where are we supposed to draw them. Okay. Alternately, we've more recently been using classes. We could use classes here. We would have a paddle class, and then for each of the paddles, you call the method to move or draw it. Okay, and once again, you have essentially the same code in here that says the same test, except instead of using global variables, you use attributes of the object to do all of the testing. Okay, so same idea, avoiding repeated code. Instead of copy and pasting, that's almost always a bad idea when you're writing code. Instead, package away your repeated code into either a function or a method, and do it once and make sure it's correct once. In this example, we have a little bit of code from, once again, Pong, where we're looking at the input and deciding what we need to do for each different key. Now, this really could have been any of our games where we use different keys, okay? Very typical structure. If it's this key, do this thing. If it's that key, do that thing, and so on for each of the possible keys, okay? So what's the problem? Well, once again, it's kind of repeated code in that we're repeating this, if this, then that, if this, then that, and every time we're checking the same key against, the key map of, some key, okay? Really what we want to say is, this key maps to this action, this key maps to this action, and do the appropriate action, okay? So there's a couple ways that we could rewrite this, okay? So first of all, here is one way. This one's kind of tricky, so I've got a couple examples here. So first of all, what we're going to have is we're going to define a function for each of the possible actions. And then we have a dictionary mapping the key to the appropriate action. Note, however, in this dictionary, this is just the function name. It's not calling the function. It's the function name. And then in key down, it says, well, let's just have a loop through each of the possible inputs. If that's the key that we have, do that operation. So in particular, it says if it's this particular input that I'm considering, then look up the appropriate operation and call it. Okay. Now, this is kind of tricky. We're not used to thinking in terms of this way. So here's a simpler version of the same idea. Here I have one simple little function that all it does is print hi. I have a small little dictionary that simply maps a value to that function. And what I can say is look up in the dictionary the value 0, the key 0. What I get is a function, and I can call it. Kind of slick, huh? Now, there is one problem with this purported example. In this particular example, the operation that we do in each of the 4 actions, okay, is basically the same. We're going to change the velocity of one of the 2 paddles and either increase it or decrease it. So our first technique eliminated the code duplication that we found in checking the key and dispatching to the appropriate operation. Now our second technique is going to be very similar to address the fact that our 4 operations are similar. Let's once again assume, like in the previous video, that we have a global variable that says paddle velocity that is an array of our two paddles. Okay. So in this case, the dictionary that we have maps from the key not to an action, but basically the parameters of the action. Okay. That, well, up says that for paddle 1, what I want to do is change the velocity by -2. Okay. And for S, I want to change the paddle 0 velocity by increasing it by 2. Okay, so what I want to do is, if this is actually the key that I'm typing in, I say find out which of the paddles that I actually want to use and increase it by the specified amount that's also in the dictionary. Okay, notice the double subscripting here. So look up, okay, look up a value in look up a key in the dictionary. That gives us back a list of 2 elements. So in that list, let's look at the first thing. In other words, this offset that we're adding. Okay. So in summary, we've seen 2 techniques for simplifying long conditionals that are repeatedly checking the same variable for different values. Okay. So our first technique, simply we have a dictionary that maps the possible values to the possible operations. Now, when those operations are similar, we can actually just condense that down to a dictionary that maps from the values to the parameters of a single operation. Next, I'd like to talk about something known as magic constants. In the process, I'm going to rag on some of Joe's code. So what is a magic constant? Well, I want to explain them by example, and we're going to look at two ideas in this particular code. You'll see this is code that he introduced for tiled images. And so first, I want to point out this code here. Okay, it talks about card center and card size and defines each of them as a tuple of two values and thus a point, screen coordinates. Okay, well, so what was the idea? Okay, well, when we run this code here, okay, we are displaying a card. And part of the idea here, we need to get from the larger tiled image an individual card, the six of spades. And to do that, we need to know where each of the cards is, and which we compute by a combination of the card size and the card center. But what is the card center? Well, it's the center of the card. Okay, that's kind of obvious. But what does that mean? It means that it's halfway in between the sides. And so how do you compute that? Well, it's simply half of the size. Okay. So 36.5 is half of 73. 49 is half of 98. No matter what the card size is going to be, the card center should always be half, right? Okay, that's not captured by this code. So we'd like to improve this code by making that more explicit. So, well, what am I going to do? Well, one option is simply I'm going to come here and I'm going to define card center after card size and define it as a pair of simply card size 0 divided by 2 and card size 1 divided by 2. Okay, so if we run that, still doing the same thing. Okay. The nice thing about that is that we can change the card size. After all, if we change the file and have larger cards, we need to change the card size potentially. And so this will make the card center just automatically correct. It'll calculate it from the size. Okay. But we can do even one better than that. Okay. Notice down here that we're using card center and card size. Okay. We could just automatically put in here the idea that the card center is always going to be half of the card size, in which case we can change this formula here so that we know we want to multiply the card size times I plus a half, and similarly j plus a half for the two components. And then we don't even need the definition of a card center. Okay. We run that, and it still works. So our next example of magic constants, or magic numbers here, is going to be down in this code. Okay, so here we have the numbers 155 and 90, and here we have 300 and 200. Okay. So the idea, the word magic here is really referring to, oh, well, why is it these numbers? You know, I mean, these numbers seem to come from nowhere. They're magic. So what is the idea here? Well, when we run our code again, the idea is that when we display our code, we wanted the card displayed in the center of the frame. Okay. Well, we look at our code, the frame is 300 by 200, and we display it at 155 by 90. That's not half of 300 by 200. So here, this illustrates one of the problems of magic constants, that, you know, why these numbers? Well, they're magic. We wanted to use them. Why? Why these numbers? Well, they were supposed to represent the center, but in fact, they're not actually the center. Well, what can we do? I mean, we could just fix, okay, 150 is half of 300, 100 is half of 200, run that, and now it's more centered, yay. But, what if I use a different frame size? What if I want to change the frame size? I want to have the card still displayed in the center. And so I want that computation to be in the code here. The computation of dividing the frame size by half should be in the code, rather than kind of in my brain when I'm writing the code. So, well, let's do this. Well, we want that to be frame size 0 divided by 2, and this is frame size 1 divided by 2. But we need a name for the frame size, so let's do that. So we're going to come up here. I'll define the frame size up here. Frame size is equal to 300 by 200. And then, so down here, I can use that frame size 0, frame size 1, and then here we want frame size 0 divided by 2, and frame size 1 divided by 2. We run that, and we get our card in the center. Okay. But moreover, if I changed the frame size, if I wanted it bigger, for example, 600 by 500, and get a bigger frame, but the card is still centered because we have the computation of the center of the frame in the code. Okay. So what we want to do in general is avoid just having unnamed constants. Give them names so that someone can understand what the heck they represent. And secondly, if some value depends upon another, if some constant depends upon another constant, put that computation actually in the code, not just in your brain. Okay. Make it explicit so that if you change one part, the other part actually still works. That's it. For our last example, I'm going to combine a couple of previous ideas along with one more. Okay, so this code is also from Pong, where you're generating a ball in the middle of the field with some random velocity. Now you had to make sure the velocity wasn't vertical, up or down, but otherwise you had flexibility, and a lot of students actually generated the velocity at some angle that wasn't too near or vertical. Okay. So we look at this, and well, there's several problems with it stylistically. So first of all, these two cases of the if are almost identical. We have repeated code. The only difference is this is negated in this case, this number here. Okay, so we would like to avoid the repeated code. Second of all, okay, look at this position. We're generating the ball in the center of the canvas. Well, why don't we get across the idea it's the center of the canvas? Use the width and height and just divide those by 2 instead of using some arbitrary magic constants here. Lastly, well, these expressions that we're returning are kind of long and unwieldy and hard to understand. What's going on is we're actually returning a position along with a list of 2 elements, which is actually the velocity. Okay. So what I'd like to do there is name the individual pieces so that it's just easier to read. Okay, so here's my redone version. Okay, I'm naming the 3 pieces, the position and the 2 components of the velocity, naming those computations, and in particular the position is computed from the global width and height of the overall canvas so that I make sure I have the center even if the canvas is resized. I have some fairly arbitrary ways of generating the initial velocity. Okay, yes, those are kind of magic constants here, but in this case, I don't have a good way of naming those. I mean, those values are pretty arbitrary, quite frankly. But rather than that big long if statement before, I want to combine those, and really all I'm doing is, with 50% probability, I'm negating the velocity in the x component. And then when I'm all done, what I'm returning is the position and a pair of the velocities x and y components. That's much more readable. Okay? So, combining a lot of ideas, but one of the new idea here was that you don't want big, long expressions. Break it down into multiple pieces and name those pieces so that they're understandable.